Welcome to lesson 9.1, solving quadratic equations using square roots. A square root is the number that can be multiplied by itself to get a specified value. For example, the square root of 16 is 4, because when you multiply 4 times 4, you get 16. Since 4 squared is 16, and negative 4 squared is 16, the square root of 16 actually has two roots, 4 and negative 4. Every positive real number has two square roots, one positive and one negative. So in part A, you can see that the square root of 64 is 8, but also negative 8. For part B, this is review from a skill we learned a few days ago. The square root of 18 needs simplified, and we do that by first making a product of prime factors. So 2 goes into 18 9 times, 3 goes into 9 3 times, and 3 is prime. And this particular square root has the prime factors of 2 and 3 and 3. Well, these two factors actually make 9, and the square root of 9 is 3, so we can take that out. And the 2 that's inside there still gets left in. So the square roots of 18 are plus and minus 3 square root of 2. You could use a calculator to approximate those values, and later on in the lesson we will do that. For part C, the question has 0.01 and the square root of that. Well, if we think about what 0.01 really is, it's actually 1/100th. And by the quotient property of radicals, we can split that radical apart into the square root of 1 over the square root of 100, and the square root of 1 is 1, the square root of 100 is 10. So the square roots of part C are plus and minus 1/10. If we were to change that back into decimal form like we started, that would be the actual answer. And then in part D, we do a similar thing. We split the radical into two pieces. The square root of 49 is 7, and the square root of 25 is 5. And again, we're going to put plus and minus for all of those. To solve quadratic equations using square roots, first look at the problem as if it were a linear equation. Pretend the exponent isn't there. How would you solve that equation? Well, first you would add 36 on both sides. And then you would divide by 4. But in this problem, truly, x is squared. And in order to undo a square root, in order to undo a square, you find the square root. I'd like you to repeat that statement to yourself. In order to undo a square, take the square root. When you do that, the square root actually will undo the square. Those things cancel each other out, and x is left by itself. And then we find that the square root of 9 is the value of 3 and negative 3. So this equation has two answers, positive 3 and negative 3. Okay, another example, similarly. Let's pretend that the square is not there and solve it just like as if it were a linear equation. So on this one, the first step is to subtract 6 on both sides. And step 2 is to divide by 2, so that x squared is equal to 4. And how do you undo a square? You take the square root on both sides. Don't forget that anytime you take the square root on both sides of an equation, you always have to put the plus and minus so that you get two answers. Remember, these are quadratic equations. And quadratic equations create graphs of parabolas, and parabolas cross the x-axis up to 2 times. And so we should always be looking for two possibilities for answers. Okay, in part C, we'll start the problem exactly the same way we did the others. And then, let's see, we'll divide by 7, add 9, divide by 7, x squared is equal to, and don't be tempted to pick up your calculator, just leave the fraction 11/7. To undo a square, we find the square root of both sides. And when we practiced simplifying radicals earlier, we broke this apart so that we could find the square root of 11 and the square root of 7. There's no way to simplify that. And so the actual answers, the exact answers are plus and minus square root of 11 over 7. Now, on your homework, your math book is going to ask you to find the decimal approximations for those. And so you're going to pick up your calculator, and you're going to actually find what the square root of 11/7 is. So I'm going to grab my calculator, and the square root of 11/7 is, now hold on, approximately 1.25, if we round it to 2 decimal places. But don't forget the plus and minus, we're going to have both of those answers. So always be looking for exact answers, like these, and approximate answers, like these, when necessary. A second type of quadratic equation solved by square roots has a couple of different steps to start with. Typically, when you are solving part A, this type of linear equation, what you would do is you would distribute through that quantity. However, it is not legal in math to distribute through a quantity that has an exponent. So we can't do that. So instead, what we're going to do to get rid of that 5 on the outside is first divide by it on both sides. See, then it cancels out, and you're left with the expression that is squared. 25 divided by 5 is 5. Then take the square root on both sides. The square will undo the square root as usual, and you're left with x minus 7 equals plus and minus the square root of 5, which won't simplify at all. But you still don't have x by itself, so there's one more step left in this equation, and that is to add 7 on both sides. So the two exact answers are plus and minus the square root of 5 plus 7. And again, your calculator or your book is going to have you approximate those solutions. So I'm going to grab my calculator. Now be careful with this. When you find the square root of 5 and then you add 7, you're going to get approximately 9.24. Don't be tempted to stick a negative on that and have your two answers, because if you work the problem correctly, you're finding negative on the outside, square root of 5 plus 7, and that's a totally different answer. It comes out with approximately 4.76. So those are your two answers for this equation. Let's practice again with part B. Step 1, divide by 4. 4 is canceled. You're left with x plus 10 squared. 24 divided by 4 is 6. Then to undo a square, we'll find the square root on both sides. So x plus 10 is equal to plus and minus the square root of 6. And it just so happens that the square root of 6 still does not simplify. And so the last step is to subtract 10 on both sides. Now x is by itself, and we have plus and minus the square root of 6 minus 10. On your calculator, let's find the approximate values for them. Let's find the square root of 6 minus 10. And that value is going to be about negative 7.55. And then negative square root of 6 minus 10 is negative 12.45. Check and make sure that you can get those answers on your calculator. If you don't, please come and find me so you can ask me how your calculator works so that you can find those approximate answers. Okay, one more example, which is kind of like the previous ones, except on this example, there's no number in front of the parentheses to divide by first. So this one, our first step is to actually find the square root on both sides. When you take the square root, you're left with x minus 9, and the square root of 64. Hey, that's a perfect square. We can find that it is plus and minus 8. So the last step on this one is to add 9 on both sides. Well, this one actually simplifies nicely into two nice, neat, exact answers, because the two answers are made up from positive 8 plus 9, which is 17, and negative 8 plus 9, which is 1. So our two answers this time are 17 and 1. And those are exact, so there's no reason to find any approximate values. The last example today gives a word problem example that deals with gravity, kind of like the problems we were working with before. So a person visiting the wishing well makes a wish, drops a penny into the well. The water level in the well is 13 feet below ground level, but they drop the penny from 4 feet above ground level. So the height above the water in feet of the penny as it falls is given by this function. H of t, where t stands for time, equals negative 16 t squared plus 17. Remember, negative 16 is acceleration due to gravity in feet per second squared, and the 17 comes from 4 feet above ground level falling all the way to 13 feet below ground level. We're going to find the amount of time it takes before the penny hits the surface of the water. So let's take this quadratic equation, negative 16t squared plus 17, set it equal to 0, and solve it. And we can use square roots to solve this equation because the t term, the middle term, is missing. So let's first subtract 17 on both sides, and then divide by negative 16 on both sides. So t squared is equal to negative 17 over negative 16. The negatives cancel out, and so you're left with t squared equals 17 over 16. And then, how do you undo a square? Absolutely, square root on both sides so that t is by itself. Now remember, we should always put plus and minus on our answers. And because we're dealing with a real-world situation, approximations are going to be the way to go. So let's find those two approximate values. The square root of 17 over 16 is approximately 1.03 and negative 1.03. Oops. But you know that you can't go backwards in time, so the negative value really isn't useful to us at all. We're not even going to use that. The answer to the question is 1.03 seconds is how much time it takes before the penny hits the surface of the water. Thanks.